Yeah, I'm gonna go over number 21 from homework 4.4 part 2 again because we did in class, but I think I spent a little more time than I really need to in that one. So let's just do it a little more concisely. All right, so there's a question about the body temperature. I'm just gonna recall the facts. So the facts are at 5 a.m. the body was 80 degrees. At 6 a.m. the body was 70 degrees. The surrounding temperature is 60 degrees, and his original body temperature was 98 degrees. Okay, and then what else do you know? Do you know, is that all we know? Yeah, I think that's it. And you're trying to find out what time did he die? Is the question. When did he die? All right, so we're using the Newton's law of cooling, which says it's basically the same equation we've been looking at. They just changed D for A, right? There's another version of it, by the way, which instead of actually writing just the D, they write the difference of the two temperatures to be more to give more information, but really the same thing. So your starting temperature or starting difference in temperatures, any difference in temperatures, and everything else is the same, e to the kt. Yeah. Okay, so we're gonna do the same thing as before. We're gonna first figure out what k is. So when I'm thinking about my variables here, with this information, I'm gonna start by, because I don't know what time it was at his original temperature, then I don't have enough information to use that as to figure out my original D naught. So what I'm gonna use instead is these two values. I treat this as the starting difference, or this is starting temperature, this is an ending temperature. And with that, I can figure out what K is because it says the temperature is changing exponentially. All right, so here's the first iteration of this. I'm gonna treat D naught as being the difference in temperature from his temperature and the surrounding. So 80 minus 60 is 20. And then the ending difference is going to be the ending temperature minus the surrounding temperature, which is 70 minus 60, which is 10. Okay, and then what else? So the K is the how fast it's changing, right? How fast the temperature is changing, and that's what I don't know. But I do know T. I know T is time that has progressed from 5 a.m. to 6 a.m. That's exactly 1 hour. That's 1 hour. Let's just say 1. Just keep in mind we're in hours. All right, so then I'm going to solve this equation with these numbers in mind. And let's just do that on the bottom here. Okay, I'm going to do it right over here. So D is 10, D naught is 20, e to the k, which is what I don't know, and t is 1. Okay, so solve that thing. To solve it, first I divide both sides by 20. I get 10 over 20, which is a half. It's equal to e to the k times 1 is just k. And now to get rid of that e, I can just ln both sides. So ln, ln. I have ln of a half is equal to k. So k is equal to ln of a half. All right, that's nice. Nice and concise number. Okay, so now I got to go back and figure out when did he die. So how do we do that? Let's see. Well, this time I want to treat his starting temperature as what was the starting temperature? His starting temperature was his original temperature, which is 98 degrees. By the way, some of you guys, instead of doing his starting temperature as 98, you chose to think of it as starting from this, and then that's okay. You're just going to get a negative value. But I'll talk about that at the end after I finish doing it my way. So 98 minus 60 is 38. That's the difference in temperature from his starting temperature, where he started at, and where he ended at. Let's take the 5 a.m. value. You could use either one, 5 a.m. or 6 a.m. But let's use 5 a.m. because that's a little easier. little smaller number, right? So 80 minus 60 is 20. Okay, so 20. Okay, I don't know why I erased k. K was the same thing as before. Maybe let's just write it in the same color though. It's ln of a half. And then t is the thing that I don't know, right? T is what I'm trying to figure out. I want to know how much time has progressed, how much time has passed. Okay, so we have all our information. Let's just plug into the equation now. And let's do it over here in black. So d is equal to 20. And d naught is equal to 38. It's e to the ln of a half times t. Right? Yeah. Okay. So then next thing I'm going to do is just divide both sides by 38. I get 20 over 38 is equal to e to the ln of a half t, ln of a half times t, that is. That should be more clear here. It's not ln of a half t, it's ln of a half times t. And at this stage, I can get rid of that e by just lning both sides again. So ln, I have ln of 20 over 38 is equal to ln of a half times t. So to get t by itself, I just divide both sides by ln of a half, and that will be my answer. So t is equal to ln of 20 over 38 divided by ln of a half. And I can approximate that by plugging into the calculator. So my knees blocking the way. Let's plug that into the calculator now. Okay, I'm just going to type it in. ln of 20 divided by 38 divided by ln of 1 divided by 2. Okay, just like this. On the bottom, ignore the top. It's just ln of 20 over 38 divided by ln of 1 over 2. And I get to the nearest, let's go to 3 decimal places, 0.926. Okay. So that's how much time has progressed. So like I was saying before, if you had chosen the starting value instead to be switched, you could have switched these and thought of it as the starting time as being the 5 a.m. and the ending, the time that you're trying to figure out is being whatever time before that was. So if you had reversed these two, then you would have gotten the same value but with a negative. That means you would have that's how much time ago it was. But for me, the way I did it is I'm thinking of as starting time was when he was at his correct temperature. Ending time is at 5 a.m. And between those two times, then 0.926 of an hour has passed. So what time was it? We have to go back 0.926 of an hour. So you just subtract this portion of an hour. Okay, let's do that. Let's erase it because it's kind of getting messy. Sorry. Let's just keep that first fact in mind that 5 a.m. is the 80-degree mark. 0.926 of an hour is transpired, so 0.926 times 60 minutes to know how many minutes have passed. If I multiply that, I get about 55.55, so 56 minutes to the nearest minute. So about 56 minutes have passed. Yeah. All right. So 56 minutes have passed to get me to 5 a.m. So that means he died 56 minutes before 5 a.m., which would be 4:04 a.m. That's the answer. He died at 4:04 a.m. And then 56 minutes passed and his body temperature was then at 80 degrees. There it is.